Non-broadcast multi-access environment support in OSPF. We saw earlier there is a frame relay PVC running in between R1, R3 with the ID 103 on this side, 301 on the other side. Likewise, there's another PVC 401. So if R4 wants to talk to R1, they have to send the traffic to 401. If R1 needs to send a packet to R3, they should send it to 103. If R1 sends to 103, this is like on pipe. If you put in the pipe, it will come out in the other end of the pipe. Likewise, if R1 wants to talk to R4, it will put in this end of the pipe. You need to know only this end, 104. You no need to know R1, no need to know about this one. Not needed. Who needs to know about 401? R4 should know. You understand? This is like a gateway, frame relay gateway. And if you notice, there is no PVC in between. In lab, it is easy to put like this. A PVC, I can do it very easily. I need to just give another number, let's say 304 and 403, something like that, and I can tell to use this PVC. So what R4 will do, whenever it wants to go to R3, it will deliver the packet to 403. Whenever it wants to go to R1, it will deliver the packet to 401. You understood? So we call this as full mesh. When you have this, you call it as full mesh. But in the real world, it is very difficult to see this because the frame relay is costly, very costly. See, if you have full mesh, then this first method is good. But in real world, we don't have full mesh, so it's not okay to use the first method, the default mode. It is not okay to have the first mode. Okay, now let us now focus on this one first and see why it is not recommended for hub and spoke. What do we have now? It's a hub and spoke. Do you agree with that? Now we are going to see why this is not a suitable one for hub and spoke. We are going to see why this is not a suitable one for hub and spoke. For that, let us see how non-broadcast behaves. So the default mode in non-broadcast, the first point that I want to say is default. Second point, it is for neighbors in same subnet. Meaning, if the neighbors are in different subnet, you cannot go for this. I'll explain you what it is. Before that, let me finish writing the other points. The next point is there is a designated router and backup designated route elected. Now, the 4th point is very important point. Neighbors neighbors need to be configured manually. Reason is no multicast on this mode. Now, you see, there is a DR-BDR election. Because there is a DR-BDR election, because there is a DR-BDR election, because there is a DR-BDR election, the topology need to be a full mesh. Full mesh. All right. Now, what is the connection between full mesh and DR-BDR? Let's see. This is a topology. Oh, this is a topology. Let's say this is becoming DR. Assume this is becoming DR. And this is becoming BDR. And this will be other. Now, if this link breaks, can these two talk? You don't have PVC. You don't have PVC, isn't it? The PVC will break if this link breaks. Do you agree? Now, because there is no R1, R3 will say, okay, I am a DR now. And R4 will also say, I am a DR. Why? There is no hello packets coming between the neighbor. After you form neighbor manually, every 30 seconds, the hello packet is supposed to go. But because there is a break in the link, all the PVCs have gone down and no hello coming from R1. Not coming. You got it? Oh. The hello is not coming. So, that is what? Election is happening, but who is competitor? Can this one talk to anyone? No, this link is not there. This link is also not there. Not possible. Yeah? It is not possible. Fine. What is next? For this reason, we need to go to other modes. Why? For this hub and spoke, this is not a suitable mode. Why it is not suitable mode? Because there is a BDR and DR election. If you say no, I don't want to go with another mode. See, the recommendation, the best method, the best way is go to the next mode. Try this. Try the other mode. But if you are saying, no, I don't want other mode, I want to manage with this mode, then what you can do, you can set priority 0 on all. So that there won't be DR-BDR election. You understood? That's all. You understood that now? Very well. Let us go to the lab. And what are the other points here? The neighbors need to be in same subnet. If you see here, this is also 10.0.0.0. This is also 10.0.0.0, 10.0.0.0. They're all in same subnet, right? Only then you can have this mode. Next. For full mesh, it is recommended, and the neighbors need to be manually configured. Fine. Let us now go and see what is already configured by us in the previous class. We did some configuration. Let's check first the OSPF, show IP OSPF neighbor. I do have a neighbor. See, there is a DRBDR election, which we do not want. And if you see show interface serial 1/0, you can see here Cisco frame relay, Cisco LMA type, frame relay is the encapsulation type. We did this in the previous class. Next is show IP OSPF interface serial 1/0. You can see here the hello packets are sent every 30 seconds, and dead timer is 120, and the network type is non-broadcast. The priority is 1. Now, this is not a full mesh, this is hub and spoke, but if you wish to manage with this mode, show run section router SPF. You need to set priority 0 here. Let me show you how to do it. Go inside OSPF. I remove this neighbor. Okay. And now I'm going to say neighbor this priority 0, meaning I'm telling my router, I'm telling which router, router 1. I'm telling router 1, priority 0, meaning don't expect that guy to participate in the election. Same way, I'll also do here. Clear IP OSPF process. You have to do the same thing on the other router as well. Yeah. Show IP, show run section router OSPF. Priority 0, 0. I have configured the priority as 0, clear IP OSPF process now. You will not find DRBDR now. Show IP OSPF neighbor. You see, it's in attempt. Give some time. The neighbor will come. It is attempting to form neighbor. See two-way. That's all. They will continue to be in. Yeah, you see, because there is no DRBDR, it is going to be in two-way. So what I can do, in this condition, I can go only to R1 and say IP OSPF, sorry, interface serial 1/0, IP OSPF priority 100. So only R1 will be a DR. If R1 goes down, will there be any DR? Yeah, that's what we want. We don't want any others to become DR when the hub goes down. You understood? Hmm. So to make R1 as a hub, we have given priority 100. So now show IP OSPF 2A. That's all. They are 2A and D are other. What about 3 show IP OSPF? You see, R1 is seen as BDR, but soon it will become a DR. And what about R4? Show IP OSPF. Okay, they're all seeing as a BDR now, having full relationship. Soon R1 will declare, because there is no other BDR to compete, R1 will become a DR. Whereas R3 and R4 will continue to be DR other. Anyway, this is not a recommended one. I'm just showing you. Okay, I'm just showing you that you can do like this to manage with it. Now let's move on to the second method. Point to multi-point. Point to multi-point. See here, second point is same. Okay. Second point, same like above. Okay. You understand what I'm saying, no? Neighbors need to be in same subnet. And then, yes, all other things are different. No DR and BDR. And then, any topo. Neighbors are dynamically, no, why configure? Dynamically learned. You are not going to configure, no? So one point which I want to add, which I forgot to add in the, yeah, one point I forgot to add in the first mode. The first mode, I forgot to add one point. Timer, 30, 120. And it's the same point here. Yes? Okay. So let's go and check this. What I'm going to do first is, I'm going to remove OSPF first. No IP routing. No IP routing. It will remove all OSPF. Then I put IP routing. I'll do the same thing on other two routers. Okay. So we don't have OSPF. Now I'm going to enable OSPF. Interface serial 1/0. IP OSPF 1 area 0. Interface loopback 0. IP OSPF 1 area 0. Sure. What is that? What is correct? Area? 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 Z. Z. No, no. Z. 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 Not G. G. Z. Z. 0. I've enabled OSPF on R1. I'll also enable on R3 now. Interface loopback 0. IP OSPF 1 area 0. Interface serial 1/0. IP OSPF 1 area 0. The neighbor won't come. Why? Because the default mode is non-broadcast. Yeah? Will the neighbor come? Neighbor won't come. See, show IP OSPF interface serial. The default mode is non-broadcast. But we are going to make it as what? Point to multi-point. How to do that? Let me do it on one router. Sorry, that was something. Now let me do it on one router. Like this. Enable config T interface serial 1/0 IP OSPF 1. Sorry, IP OSPF network type. I need to do it on one router directly, then I'll try to use this notepad. R1, okay, I'll go to R1. IP OSPF network type. Okay, no need of network type. You no need to put the type. It is only point to and I'll paste this on R3 and R4. Done. Now you can see the neighbors are dynamically discovered, but there won't be DR-BDR. Show IP OSPF neighbor. See, full relationship, no DR, no BDR. And the default priority will become 0. Automatically it will go to 0. 0. 0. Okay. Very good, very good. Now you said correct. You understood all this, right? Now the third one is the combination of first two. If you see here the word point to multi-point, which we just did, is here, and non-broadcast is here. So the best of both is what makes this one. This is Cisco standard. All these three are Cisco standard. Now the third one is what we are focusing now. The best of the first one. What is the best of the first one? Neighbors are manually configured. That is the best. Why it is best? See, you have a frame relay in the middle. It is an untrusted internet. So configuring neighbor manually is more better than dynamic discovery. It is seen as more secure. You understood? Now, what is the best of non-broadcast? Neighbors are, sorry, I made opposite. The best of this one is there is no DRBDR, correct? The best of the non-broadcast is, the best of the non-broadcast is manually need to be configured. So if you like this, then you can go with this mode, okay? Let's do. I'll again remove OSPF, no IP routing, and then IP routing. I'll do the same on no IP routing. On 3 and 4. All right. Now let's do OSPF. I'm going to say IP OSPF network type point to multi-point space non-broadcast. That's all. Now when I paste this, I'm expecting neighbor to be dynamically discovered. Right now, if you see, there is no neighbor. Show IP OSPF neighbor, no OSPF. Show IP protocol, no OSPF. But now I pasted this. One more thing I need to add. Yeah, must be in same area. Should be in same area. Same subnet, same area. Those are in. Okay, you can see the neighbor is already loaded to full. Show IP OSPF neighbor. You can see neighbors are dynamically discovered and no DRBDLH. Hold on. Show run. Yeah, neighbor should not be dynamically discovered. Maybe I did not remove this OSPF. How can neighbor come dynamically? Neighbors have come dynamically, which means there is something wrong. Let me shut down the interface for a while and restart. I want to see if any configuration is still here. Do show run section router OSPF. Okay. Okay. Let me say no shutdown now. There won't be DR-BDR election, and neighbors need to be manually configured. Neighbors should not come automatic. See, neighbor is not coming. Show IP OSPF neighbor. It is not going to come. Then how it come before? Because the time I didn't configure few routers when I configured R1. R1 was already configured, but R2, 3 and 4 was not configured. So it needs to be done and then shut down. So some misconfiguration was there. See, the neighbor will never come up. Show IP OSPF interface brief. You have OSPF running. All right. See, this is pointer, multi-point. Wait a minute. I also want to run on interface Linux. Correct. So the neighbor is not going to come. Show IP OSPF neighbor. It's not going to come unless you specify the neighbor manually. Good news is there won't be DR-BDR. Okay. Now let's do it. Router OSPF1. And neighbor is 10.0.0.3. Neighbor is 10.0.0. You should do it on both sides. Router. Even the neighbor comes, you should not stop doing. You have to do it on both sides. You know how this has come? Because there you configure the negotiation started. If one side negotiation started, the other side is still working, but good practice is do it on all routers. Show IP OSPF neighbor. You can see the neighbor is there. There is no DR-BDR election. You understood? Now the next one is broadcast. Now